We are going to go on with our magnetism and magnetic stuff. We said magnetism as the topic magnets and magnetism has got three branches, like where we look at magnetism and under this we look at magnet and their properties. Then electromagnetism, where we have the effect of current producing a magnet. Then electromagnetic induction, where I have the magnet already in place creating either electric current because of the motion, or the motion and the current and the magnet creating motion. So you're going to be looking at those things. Under electromagnetic induction, this is simply the production of voltage or EMF using a varying magnetic field. So the word varying brings about the motion and stuff. So the only difference in this and electromagnetism is that here we have something to do with motion. We do not just get a magnet and a conductor and then expect to have current. We have to put in motion as the third factor. Yet in electromagnetism, the moment you have battery and a conductor, you create a magnet. And I would just say that this is the opposite of electromagnetism, but since we have a third element called motion, then that makes it slightly different. So here, what causes the change in magnetic field is simply moving the magnet with a conductor stationary. You can have a conductor stationary, then you bring a magnet near it or away. Whether you bring it near or away, as long as there is motion, you always have current go through this conductor. Or you can get the conductor, you can have the magnet stationary, then you bring the conductor close or away from the magnet. You always have the same effect. So all that you need is magnet and motion over conductor, you get the voltage, or motion over magnet and the conductor, then you'll have the voltage. So you need the magnet, the conductor, and then the motion. Those three things are important. And now, for us to tell the direction of current which has been created, we know when you talk about voltage from Ohm's law, V is equal to IR, you can't talk about voltage and forget to talk about I. There is that element of current in voltage. So if you want to get the direction of current that has been created, after creating the voltage, you expect current to flow because it is the only way for us to tell that current is flowing. The direction of current that has been created by the motion of a magnet with a conductor, we use the Fleming's left-hand rule. Now we call it Fleming's simply because the person who found it was called Fleming's, but you just use your left hand. You get your left hand and have the first three fingers at 90 degrees like this. Now this thumb will always represent the thrust or the magnetic force, like the magnetic force. Then the first finger will always represent the field, the magnetic field. This is the force, and then this is the current. Force is in terms of motion, like the motion that will take place. Then this field is the magnet, like the magnetic field created by the magnet, and then the current is what you get afterwards. When you have motion due to the force and then the magnet in place, you have current, and that is the direction of current. You'll be using this in the generator and then in the motors to take the direction of current when you're working with those two elements. We'll look at them later. We'll exploit them more when we come to the motor and the generator. Then the factors that affect the voltage that has been created as three. Basically three. We have the strength of a magnet. We use a permanent magnet for this, and that magnet, the stronger the magnet, the larger the current that you create, or the larger the voltage that you create. Then the speed of motion. If we increase the speed of motion, then we are going to have a greater voltage again being created. And then the number of turns. Like if you have a wire, if you use just a wire, it is different like when you use a coil. When you use a coil, the effect that you get is greater compared to when you use just a straight wire. And again, when you use a coil of many turns, it creates a greater effect compared to when you use a coil of less turns. So we need to know that to increase the voltage, we need to increase the strength of a magnet, speed of motion of either the magnet or the coil, and number of turns. That is the only way for us to get a higher voltage or create a higher voltage. And under electromagnetic induction, we'll come across two laws, the Faraday's law and the Lenz's laws. These are called electromagnetic laws. And then Faraday's law simply talks about the effect of how EMF is created, and it says for you to get EMF, you need to have a change in magnetic field, the change which we are talking about here. So it simply states that the EMF induced in a circuit is directly proportional to the rate of change of magnetic flux. In other words, EMF depends on the change in the magnetic field. Then Lenz's law, for which it talks about the current. We've said whenever you have voltage, you can't rule out the fact that you have current somewhere. The current that is associated with this voltage that you create will always flow in opposite direction to the change causing it. So if you want the current to go east, for it will flow in opposite direction. It will come as if it is opposing you who is creating it. So those are the two laws in electromagnetic induction which we'll be looking at. Now, this is a brief introduction and a sum up of what we are going to look at. Then under our today's assignment, we are just going to look at the applications. I want you to go and search about the applications of electromagnetic induction. Look for the applications and then post them. Like I can write a sentence or two on all the applications that you come across. They shouldn't be less than 2. Then after writing them, just write them in your normal books, exercise books, the books that you have where you put notes, and then take a pic and then post on Class Dojo. That is enough for today. Nice time.